So let me start off by introducing myself just a little bit. My name is Dave Weller. I'm at the Southwest Fisheries Science Center in La Jolla. And my specialty is really, in the past 15 years, has been on conservation of western gray whales, a small, critically endangered population off the coast of Russia. But I've also, more recently, become quite involved with eastern gray whale studies, which is an interesting dichotomy in that the population is substantially larger. And we've been counting whales at the Granite Canyon for the past 3 weeks. We'll go for another 4 weeks. And we see more whales in the first hour and a half of the day than there are in the entire population for the West. So a lot of my thinking about data collaboration, research collaboration, and data sharing comes from a conservation perspective. And that has largely to do with my work at the International Whaling Commission, which you can imagine there's a lot of diplomacy in finagling data sharing and cooperation amongst political agendas oftentimes. And also within the IUCN, which has been kind of a treat in that it's a conservation-based organization, which also has its own share of political dealings, but also directly tied to science as well and trying to foster conservation efforts throughout the world. So that is where most of my background in data sharing agreements, research collaborations is coming from. That kind of gives you a perspective there. And really today, all that I want to do as the plenary or the moderator for this session is kind of lay out a few bones for this topic. And I'm going to allow the panel, which is 6 in number, to put the flesh on those bones. They're all going to be giving presentations. They're all highly qualified to talk about what they're talking about. And I look forward to that session myself. So collaboration, or to collaborate. The definition is to work jointly with others or together, especially in an intellectual endeavor. I think that's quite appropriate for the forum today. And then down here are a few other ways to think about it. Is to band together, cooperate, conspire. I particularly like that one. My kids do that all the time. To team up or to unite. And I think that's one of the basic concepts that we want to foster at this meeting and try and promote is collaboration amongst research groups and organizations. Sometimes collaborations result in something far better than a one-man band, for example, the Beatles. However, sometimes they can go very wrong. Very wrong. If anyone cares to wager a bet on the name of this band, I'd be happy to take that and buy you a cocktail later if you have the right answer. You want to know the word? That tie that the guy in the front is wearing is something else. All right, sharing, or to share in this case. To have or use something at the same time as someone else. And this is data sharing is really what we're talking about here. And just like collaborations, sometimes sharing goes well, and sometimes it goes not so well. And yes, those are the Weller kids on the right-hand side. And you can see that sharing is not going well there for my son. My daughter Maggie seems to be okay with it. So commonly, when we talk about data sharing, a central theme generally comes up, and that's concern about allowing others to use your data and about how they're going to be safeguarded. What kind of conditions are we going to be working in when we allow others access to our information? And I'll tell you that there are so many working protocols and agreements for data sharing out there. The North Atlantic right whale catalog, the humpback whale catalogs around the world, bottlenose dolphin catalogs on the East Coast. Everywhere that you look, you can find a protocol. And a lot of them hit on the same central themes. We're going to talk about those in just a minute. So this is extracted really from the IWC and work that Greg Donovan has done there to finesse political agreements and scientific agreements amongst countries, sometimes with quite different opinions on things. But I think it's important to go over these because I think Greg has really hit it right on the head. The first is the question of data availability is complex and sensitive. It requires a balance between scientific needs and the rights of the scientists who have invested time and effort to gathering those data. And three fundamental themes prevail here. The first is that data represent a significant temporal and financial investment by scientists and research institutions. Use of their data by others should be accompanied by appropriate data safeguards. One of those being the right of first publication is an accepted scientific norm. In addition, if important management and conservation decisions are to be made, they should be based on a full scientific review of both data quality and analysis that can be independently verified. So if others are asking for your data and you allow them to use those, there's another step there in which the quality of the data being used needs to be verified and checked. And before an interpretation of those data can be made in the absence of the data collectors, at least an independent review should take place of those. That sometimes and oftentimes happens at the journal submission level. I'm actually not sure where to point this thing, so if you get hit in the eye with the laser. Open source, open notebook, open data, open access. And you guys are probably familiar with those terms from last year's panel on the same topic. And I think you're going to hear a lot more about those by two of the panelists today, Melissa and Jim. But this is really the emerging trend in scientific research, in data sharing, and in cooperation and collaboration. And this is extracted from a grant application to the National Science Foundation. So this is really kind of where we're at in terms of science and what we can expect in the future, is that there's a call for open source. It means your data codes, your models, other things. Open notebooks, your notes on your methods and your techniques. Open data, it speaks for itself, and then open access. Funding agencies more and more are being pressured to and also requesting this type of open science approach. So let's just take a look at what the National Science Foundation is requesting. It advocates and encourages open scientific communication, expects findings from supported research and educational activities to be promptly published, and that authorship accurately reflects the contributions of those involved. It expects PIs to share with other researchers at no more than incremental cost and within a reasonable time the data, samples, physical collections, and other supporting materials created or gathered in the course of the work. And then finally, it encourages grantees to share software and inventions once appropriate protection for them has been secured, and otherwise act to make the innovations they embody widely useful and available. I know there's probably red flags going off in everybody's mind, and that's common and it's to be expected, and I'm hoping that the panel will address these types of issues. I'm not going to try and get there today, in this talk, but I think the panel is inevitably going to go there, and we're going to talk about it during the roundtable session, certainly. But the takeaway from this particular slide is this is the way that things are headed. Everyone's going to have a slightly different twist on it, but I think we can expect this to be more and more common practice in the future. Open source science. This is one fun example of open source science. And I would direct you to this paper by Gowers and Nielsen. And just the title alone is so awesome to me. Massively Collaborative Mathematics. Now, in Southern California, I would recommend changing the title to Totally Massive Collaborative Mathematics Dude, an exclamation point, or smiley face or something at the end. But look at this. This is pretty cool. The Polymath Project proved that many minds working together can solve a difficult mathematical problem. And the goal of the project was to use blogs and wikis to collaboratively work on an unsolved problem in mathematics. In less than 2 months, it was announced that the Polymath participants had worked out an elementary proof, and that paper has now been published. So kind of a cool way of open science working, and even using some of the things that I'm going to suggest for our panel to discuss, the use of innovative, contemporary techniques to share data and correspondence, things like blogs and wikis, and other ways to communicate with each other. So the panel objectives, 2011, and I have to say that last night I read the report again from last year's panel, and our objectives this year are identical to the objectives last year. Very little has been changed, a word or two. So it could be considered plagiarism, I guess. Don't hold me to that one. But what I'd like to see our panel work towards are these three things. Outline regional priorities for research collaboration and data sharing. Of particular interest are collaborations between groups working on the same species. Photo ID catalogs is an example. And collaborations between the US and Mexico. And usually when I think about Southern California, I'd like to also think about northern part of Mexico and Baja, at least. The second objective is to discuss how to build a data sharing infrastructure for the Southern California marine mammal research community. And I think Jim and Melissa. Jim, are you here? Would you raise your hand? Because I don't actually know you. There you are. I think they'll be able to help us think about that because they're really working on these pulsing brains on the right coast and the left coast, how to manage and deal with some of those data sharing infrastructure issues. And then finally, to evaluate data management and sharing techniques such as online metadata sources, integration of multiple media data, databases, and web-based interfaces. And I know you guys have worked on this probably more than I have, but that's one direction that I'd like to see us discuss and come up with some plans or ideas about how to move forward with those. So a case study. And I want to say that Madalena Yartzi, sitting right here, will be talking about bottlenose, California coastal bottlenose dolphins in particular during our panel session. So I'm not going to go too far into this. But I talked to Madalena about this, and I want to at least outline what I think is a priority X for our panel. Priority X, why X, right? So I was working on this, and my son said, "What are you doing?" He's 4. I said, "Well, you know, I'm putting together a talk for a group of marine mammal scientists tomorrow." I said, "What priority do you think California bottlenose dolphins should be?" And he said, "X." I said, "Okay, priority X." I said, "Why?" He said, "Because it's cool." So instead of priority 1 or priority A or anything else, it's priority X, which you kind of like. And because it's cool. So let me just give you a couple of tidbits about coastal California bottlenose dolphins. Photo identification studies were started in the mid-1980s. Dennis Kelly, actually sitting here somewhere. Dennis right here was one of the very first to start snapping dorsal fin pictures. The population size from some work that we've done in 04-05 puts the population, the marked part of the population, at about 323 individuals. You can see what the CV is around there. So less than 500 individuals in the coastal population. The distribution for the most part is less than 1 kilometer from shore. For about 90% of the sightings, Madalena's got some sightings further from shore in the Santa Monica Canyon area. We've got genetic differentiation between coastal and offshore animals. And then finally, the Southern California bite is highly industrialized. And we're working now, we've got a manuscript in preparation on contaminant levels in these animals, and they're extremely high. So the population is vulnerable. It's not listed as such in any formal way, but you can tell it's a small population. It's got a limited distribution. It's genetically distinct from its offshore counterparts, and it lives in an area that's really quite industrialized. What we've learned about the population today has drawn upon collaborations, research collaborations, extensively. And we would be nowhere as far along in terms of our knowledge about the population working alone in that one-man band. But we've needed to draw upon the beetles to help us out. Population dynamics, contaminant assessment, habitat modeling, health and reproduction, genetics, stranding networks. They've all informed us about this population. And this just gives you a glimpse, in fact I say some because there's many more, and many of you folks in this room have helped contribute to our understanding of the population. So it's just some, but it gives you a snapshot about how many collaborations are needed really to inform, to best inform a knowledge about a particular species. And this includes internal collaborations within, for example, my institution, my affiliation in Southwest Fisheries, and also outside of our institution. And it involves numerous different scientists with numerous different backgrounds, very multidisciplinary. Some of these folks don't even work on marine mammals per se, but they've got an expertise in a particular piece of information that we're interested in. So here's kind of the setup, and I hope this doesn't overlap too much with you, Madalena, but as far as I know, and I just learned about one in San Pedro today, but there's research groups working down here in Ensenada. This is, again, on coastal bottlenose dolphins. The group that I collaborate with Scripps and Southwest Fisheries, is here in San Diego. They're also, SIO is also working out here in some of the offshore islands. Up here in Santa Monica, we've got Madalena doing her work, Tony Frohoff and Michael Smith. Mike are up here in the Santa Barbara area, and then finally we've got Daniela Maldini up in Monterey Bay. So we've got a number of research groups working along the coast. The cool thing about this is that this is the range. This dark line is the range of the population. So the same individuals that we catch down here photographically, we also catch up here, here, and here. So I think this is the right project for an integrated data sharing infrastructure to be evolved, to take place. So I think California coastal bottlenose dolphins, in my book, are priority X. And I think it's one thing that I want to take into the panel and bring into our roundtable discussion, because we don't have that currently. Madalena is going to talk about a neat project that she and her colleagues have recently completed that shows the potential for this type of thing. But here we are, right in our backyard, Southern California. I think it's time for us to talk about this seriously and see where we can go with it. So now I want to introduce the panel members who've been doing a lot of deep thinking on this topic. If only we still wore ties and white lab coats. Here we go. I'm just going to quickly go through these, and I'd like just to introduce the panel members, and then you can read their titles there themselves, and you can see it in the program. But Bernardo Alps is here. Bernardo, can you raise your hand? There he is. Cabrillo Marine Aquarium. Madalena Biartzi from the Ocean Conservation Society. John C., who most of us affectionately call, from Cascadia Research Collective. Jim, your last name?
Regetz.
Regetz, okay. I wouldn't have guessed that, so I'm glad I asked you. Jim is from NCES up in Santa Barbara. Elisa Schulman-Yaniger from ACS here in Los Angeles. And then Melissa Soldevilla from Duke University, and she's part of the OVIS CMAP. I would just like to say that, Melissa, in your talk, and you get the award for the best acronym, because when you actually spell out what OVIS CMAP stands for, it's about this long, and it's incredible. So they win the award for it, and I'm not going to give away what it means. You can share that with everybody. I was impressed. I have priority X, right? And you've got OVIS CMAP. A world of difference. So those are the panel members. You'll meet them if you attend the session this afternoon. And we've got a lot of thinking in front of us. And none of it is terribly complex, but there are issues that we need to work through. Data sharing and research collaboration is a sensitive topic, but I think that we can successfully do that. Certainly other groups have done this globally, and I think that we can accomplish such regionally. So I just want to say thank you, and that I'm really indebted to Greg Donovan, Randy Reeves, Justin Cook, Bob Brownell, Baron Wurzig, Greg Campbell, and Alex Caceres for insightful discussions about this topic. And if you want to contact me about any of this, please see me here, or you can email me at that address. Thanks very much.